All right, welcome everyone. Welcome to the Teleport Application Access webinar. Let's get started and let's walk over the agenda first and see what we're going to address during this presentation and demo, right? So first, like the main topic for today is obviously secure access for your web applications, right? And we're gonna talk about the actual securing web applications problem first, right? The various issues that users and engineers encounter when they're trying to get a secure access to their infrastructure and web applications, what it means, and how Teleport application access can help you solve some of these issues, right? So why we're building Teleport application access for you. Now we'll also take a kind of peek into the application access architecture, so you folks understand how it works and what kind of benefits it provides, you know, what kind of features it has and what kind of use cases it can cover, right? So to see if it's would be a good fit for you to use. And Teleport application access and Teleport itself is an open source product, right? So everything we're going to be talking about today and seeing today during the demo, you will be able to just go ahead and try it out yourself right after this presentation. And finally, we'll do, you know, a hopefully informative and detailed demo. So we'll see Teleport application access in action. And at the end, we'll probably have some time left for a Q&A. All right, so let's get into it. So what is the actual problem that we're trying to solve here, right? So in today's cloud native environments, engineers and just regular users usually have many different endpoints they need to be able to log into, which are often spread across many networks, right, such as data centers, various VPCs of different cloud providers, and so on and so forth. And so despite all these security obstacles, which make accessing these systems quite a hassle, they don't actually comply with security standards, such as SOC 2, PCI, FedRAMP, or others for multiple reasons. So first, there's no usually great way to ensure consistent user identity between all these different environments, assuming there's even any security at all. So organizations are often forced to use directory-based authentication services, which are difficult to set up and expensive to maintain, or worse yet, they resort to using shared credentials, which makes it pretty much impossible to answer the questions like who did what in the system. So in addition to the inconsistent identity, we often also issue long-lasting security keys and username, password, credentials for different systems that can be leaked and compromised. And so if the past decade, with its 10 out of 15 largest data breaches in history has taught us anything, is that the question is not like if my password gets compromised, but rather when, right? So persistent credentials are not great from security standpoint. So finally, there's no good visibility into what users are doing when they are logged into these systems. And having a detailed and accurate audit trail is very important for security and compliance reasons. And so all of these combined with lack of identity information, persistence, and shared security credentials, it becomes kind of pretty easy to see that calling a system without these properties secure would be somewhat of a stretch. So now, if you notice when talking on the previous slide through all these points, I never explicitly said server anywhere, right? And because that's because this is one of those cases when generalization kind of works out in our favor, right? So all the points that I just made can be equally true for accessing servers, databases, and in our case, web applications, right? Which are our main topic for today. So historically, Teleport started by making it easier for engineers to connect to servers and Kubernetes clusters. And when talking with the community about what problems they want to solve with application access, they shared a very similar feedback with us. So for many users, accessing their developer infrastructure is pretty frustrating because they can only get to it via VPN, and I can speak to it from experience as well, right? Pretty much majority of engineers and users experienced this themselves. At the same time, with all these security obstacles, there's security compliance problems with tracking who is doing what in these systems. Now, many of our users also need to secure access to their operational control panels. So every company has a slew of their home built ones and a lot of open source infrastructure dashboards like Kubernetes dashboard, PHP MyAdmin. All of these are famous for not having a very strong security and could benefit from a solution that kind of enhances their security capabilities. And then there's compliance issues for applications that hold customer data. This might be your own internal kind of operational applications, or this could be the customer's infrastructure, such as a managed service or a dedicated tenant. And in such a use case, your customers will be imposing any compliance requirements that they have onto your company. And so we're building application access to help solve these challenges. Now let's go ahead and take a look at how Teleport application access works, right? In a little bit of a detail. So for those folks who are not yet familiar with Teleport, those that are new to Teleport, it's an open source product that provides secure access to your infrastructure. So now for a quick architecture tour, like very quick, I promise, let's walk over the main pieces, right, of Teleport architecture. And so two of the components that are common for all types of access, like servers, databases, and applications, like in our case here, are Teleport Auth or Auth server and Teleport Proxy server, right, which are depicted here with these rectangles. So Proxy server is the cluster's authentication gateway. It is the main user-facing component, and this is where all the clients connect to when they want to, let's say, connect to a web application, right? So you can see if the client wants to use like a browser to connect to the application or use curl to call an application's web API, this is the proxy's endpoint is where they're connecting to. So proxy also serves the cluster's web UI, right? And yeah, like I said, it serves as a web UI and as a cluster authentication endpoint. Now, auth server, which usually sits somewhere deep in your infrastructure and not accessible from the outside, is the cluster certificate authority. Auth handles user authentication, authorization, integrates with SSO providers and issues short-lived client certificates to users, which Teleport uses for authentication with everything. So together, proxy and auth comprise what we call an access plane, right? So the access plane has a number of additional kind of functionality to it, such as access workflows, for example, which allows the users to temporarily elevate their privileges and gain access to resources such as web applications, which they normally don't have access to. So finally, Teleport application access server, so these two components here, they take care of forwarding web applications traffic from the proxy to the target applications. So app server establishes an SSH reverse tunnel connection back to the proxy over which the web application traffic is forwarded. So the actual applications that are sitting behind these app servers, they can reside anywhere, right? They can reside in a cloud provider VPC, in a private network behind a firewall, and completely be like inaccessible from the outside, right? So as long as the application servers can dial back to the proxy, these components can pretty much reside anywhere. So there are multiple ways users can connect to these web applications, right? So one is by using a web browser, obviously, and we will see this kind of in action during the demo, is when users would connect to the Teleport proxy, and which provides an web application catalog, and they'll be able to kind of choose a particular application they're interested in and navigate to it using their web browser, right? Or by navigating directly to the application's public address, bypassing proxy pretty much completely. Another way application access also supports CLI access flow, right, which is suitable for like various programmatic API calls and things like that. And so this is also supported when the users, for example, may want to interact with a particular application's API using tools like curl or Postman, or even programmatically. And so one cool thing about this architecture is that even the applications that don't necessarily support TLS, or potentially even lack their own authentication capabilities, can be put behind the app access and take advantage of enhanced security in the form of mutual TLS authentication, role-based access control, and so on and so forth, like session recording. And we're going to take a look at both of these scenarios, accessing apps with just your browser and calling their APIs during our demo. Right, let's move on. Before we dive into the demo, actually, let's just recap some of the features that application access provides. Right, so first is obviously quickly finding and connecting to applications, so your users can gain fast access to web apps and control the user access by role. So Teleport maintains a dynamic catalog of web apps that users can quickly find and connect to. And the user's access authorizations allow them to only see access apps that they have access to. Right? So, for example, the role an engineer has should dictate whether or what kind of access they have to a particular web application. So this allows companies to practice least privilege access policies with their internal apps, for example. Now, adding compliant security to apps without modification is another kind of cool part about this, is because every organization probably has apps with no security controls whatsoever, and many more with very simplistic, unintegrated username, password credentials. And so Teleport's ability to proxy authorized access into applications allows you to essentially wrap compliant security around each user session without necessarily having to modify a third-party app. So you can restrict access to just the users who should have those privileges and capture their activity for future auditability. This also helps you obviously eliminate the need to manage a lot of shared secrets. So finally, supporting role-based features in custom apps is also pretty cool. So this is more helpful in a case where your engineers are creating your own internal apps, right? Using app access to add SSO authentication flow, and even implement authorization using information provided by Teleport in a JWT tokens, right? So we'll see this during the demo, but Teleport sends a signed JWT token with each web application request, which the app can integrate with to potentially implement authorizations in the app itself, right? So some third-party applications actually support JWT authentication out of the box. All right, great. So now it's that time, right? So let's go ahead and jump into the demo. Let me figure out how to close my presentation here. And for the demo, I'm going to start by logging into my Teleport cluster, right? So you will notice this is, for folks who are not yet very familiar with Teleport, this is what the Teleport proxy UI login screen looks like, right? If you remember from our architecture diagram, proxy is the only user-facing component. And here I have a couple of SSO providers configured. So I'm just going to go ahead and use GitHub to log into my cluster. Right, so with this cluster, I have a handful of web applications connected to it. And once we're inside here, let's navigate to the Applications tab. So this is the cluster's application catalog, right, that displays all web apps that are currently available to me. So you will notice I only have two, right, which is hardly a handful, like I mentioned before. And the displayed applications obviously are subject to users' authorization check. So in my particular case, I only see these two just because my teleport user's role, and I'm logged in as this Roman T user, as you can see in the top right corner. My role only allows me to see like these two applications, and let's go, before actually trying to do anything with them, let's go to this team section here and inspect my user, right? So you can see I have the admin role in my control panel. And if I go to my roles tab and pull up the description of my role, you can see that this admin role, despite being called admin, right, it actually only allows me to see only applications with these particular labels. So teleport role-based access control model relies on labels to for like authorization decisions, right? So every resource you connect to teleport, which in our case is web apps, can be marked with static or dynamic labels, which are then used in RBAC to allow or deny access, right? And so in my particular case, my role only allows me to see the applications that are marked with environment label with values like home and dev, right? Which is why I see only these two. And we'll take a look at how I can gain access to the other applications in a minute as well. So now these applications, like I mentioned, they can be deployed anywhere, right? So in my case, most of the apps I'm showing during the demo are actually running just in Docker containers on my laptop or on my local network. And let's start with something simple and just access one of these apps. So I'm going to start with this dumper app. And the dumper app is a very simple web app that just dumps all the headers of the request in the response, right? And this app actually, it comes built in with teleport application access. So you can enable this application just by a configuration parameter. And it's not super useful, but it does have some troubleshooting and debugging value to it, which is why we included this. So for example, you can make sure that things are working correctly, right? And it also allows us to actually inspect the request of particular HTTP request that teleport application access sends to kind of each application. So for example, here you can see, let's see what we have here. So first we see that there's a set of these X forwarded headers that teleport injects into each request with information about like original, host name, about the target application, protocol, and server name, and so on and so forth, which is sometimes useful when you want to integrate with various reverse proxies and so on. Now, one particular interesting bit of information is this teleport JWT assertion header that we see here. This is a signed JWT token that teleport injects into each request with proxy to web applications, which potentially applications can use to automatically authenticate and authorize the user. We'll comment back and take a look in more detail at this kind of JWT token in a few minutes later during this demo. Now, other types of applications that can benefit from additional protection are various, control panels, internal dashboards. Like in my case here, I have this control panel for my router. So routers, don't usually boast high security and are better off not being exposed on public internet pretty much at all. So I don't have like one of those traditional routers, unfortunately, or fortunately. I don't know, I have this like Google Nest router, which only serves the status page, which is just connected to my application access cluster as well, right? So, but this way you could also connect like your own router page or any other, like we have folks who are using application access actually internally to connect to their Synology dashboards and so on and so forth. So now, as I mentioned earlier, there are actually more apps that are connected to my cluster, which we can currently see, right? Just because of my users' permissions. So now let's take a look at how I can use this access workflow system, which I mentioned before, to get access to other applications, right? So this access workflows system allows me to temporarily elevate privileges in order to gain access to services that I normally don't have access to. It's built on top of role-based access control. And what it comes down to is to a user's ability to request another role, right? So my user right now, as we saw, has an admin role, which only allows it to see like those particular applications. I also have another role that is called app, which if we take a look at it, you can see that it allows access by a wildcard to like everything pretty much connected to this cluster, right? And let me go ahead and request a role for my user. So I should go to the activity tab, access requests, and let me put in an access request for this particular role. So I can put in like an optional reason for request, right, and send it. And so normally request went to a pending state. Normally, access workflows can be integrated with third-party services and tools like Slack or Mattermost or PagerDuty. So authorized people could go ahead and take a look at particular access request and approve it or decline it. In my case, I'm going to do it like a simple way and just approve my own request from the terminal. So I'm going to do this in background real quick. Right, so I've approved my own request. You can see it went to the approved state right now, and now I can press this assume button to assume an additional role, right? So for my session. So now my user should have access to a wider range of applications that are connected to my cluster, right? And you can see that there's more appeared here, and I also have various tools like have Grafana connected. I have this kind of Node-RED application. We can just pull up here and see if it's working. So this is a like WebSockets based application, right? Which teleport data application access also supports. So I just connected it as an example of an application you can use. What else? I have pgadmin, a dashboard here to access my databases, right? Which I also connected to application access. And really, like, those should serve as a good example of the apps like that you can connect to the application access. So now let's talk a little bit about different authentication options, right? So if you have application that you're accessing like from here, it has its own login page and like makes you to go through its own authentication flow, you will obviously be kind of presented with a second login screen, right? When you go to a particular app and will be asked to log in to that app. But as we saw in the beginning of a demo, Teleport sends a signed JWT token with each request forwarded to the application. So apps can choose to integrate with it to use the identity of the Teleport user, right? So let's go back to our dumper application here for a moment, pull it up again, and see in a little bit more detail what kind of information this token carries. So let me go ahead, copy it. Then I'm going to go to just jwt.io because it has this neat token decoder and just inspect what kind of information is in the payload, right? So we can see that there's a set of like standard claims. So this section is actually the actual payload that is encoded into this token, right? As a second part of this token. So we can see that there's, audience, obviously, which is the application URL that this token or this request is actually intended for. Then there's some standard JWT claims like expiration date and not before date, right? Issuer in our case is the cluster name, a teleport cluster name that signed this particular token. Sub is a standard claim for a the actual identity of a user or something that this token is intended for. And then there is a couple of custom claims that we also inject, such as username, which in our case is actually equals to sub, and the roles of this particular user, right? So, and you can see that in my case, I have this admin role, which is default role for my user. And I also requested an additional app role using access workflows, which is also now being sent in a token, obviously, before this session. And so applications can integrate with these JWT tokens to implement their own authentication and authorization flows, right? Let's go back here. And obviously, this is kind of most useful when you are working on your own kind of internal applications and have ability to add this JWT token integration to them, right? However, some third-party apps actually do support JWT authentication out of the box, and I think more and more applications actually add support for it. And one such application is Grafana, which is, I'm pretty sure, like everyone is familiar with. So this is one of the newer authentication methods that Grafana supports. I don't think it's actually even been released now. It was merged in kind of mainline just a few days ago, and I'm running Grafana on master here to demonstrate this ability. But let me first go to Grafana, and like I'm going to it directly right now, not through the application access, just to demonstrate how it's configured. So I'm logged into it as an admin, and if I go into Grafana, like dashboard settings, you can see that I have JWT authentication enabled, and I specified the name of a header from which Grafana should extract the token, right? And you know, JWT key set file is also kind of here, so Grafana can actually validate that this token was signed by an appropriate like a teleport authority. And you can specify teleport provides a URL with key set file. So I'm just using like a local file for simplicity here, and a particular kind of claim, token claim, right, where to extract the username from. And so now with all this configuration in place, if I go ahead and try to access my Grafana instance, you can see I'm not actually presented with a login screen, but rather I'm being taken directly to Grafana dashboard. And if we take a look at my user, you can see that I'm logged in as the same user as my teleport user here, right? So because Grafana extracted the JWT token from the request and signed me in as a kind of this particular teleport user. So it mapped my teleport user onto its own internal Roman T user in this case. So JWT tokens are a pretty cool kind of method of authenticating in third-party or internal applications that support this type of authentication, just because it basically alleviates all the kind of necessity to implement this functionality in these applications themselves. Now, before we move on to the next part of the demo, which will be kind of terminal-based, we'll go ahead and take a look at this audit log tab here, right? So like I mentioned before, audit capabilities, having like an audit trail is important for security and compliance reasons. And with Teleport App Access, every application section is getting captured in the audit log in the form of 5-minute chunks that contain all HTTP requests that occurred within that interval for that session, right? So if we expand the details for a particular session, you can see that each session is also associated with a particular teleport user. So it's kind of pretty easy to keep track about who did what when connected to the application. And the information about the user obviously can come from your SSO provider. Like in my case, if you remember in the beginning, I logged into my cluster using my GitHub SSO connector. So this way you kind of get the whole chain linked together, right? Where your SSO user is getting eventually linked to a particular activity, like in a particular application. All right, so for the final part of the demo, let me go ahead and share my terminal now, because here we're going to take a look at accessing the application's HTTP APIs over application access. So Teleport supports CLI app access flow, and it will be very familiar to existing Teleport users. But again, for folks who are kind of newish to it, we can start by just logging into the Teleport cluster, right? And the command is tsh login, and I specified like my proxy endpoint, and this will take me through the same SSO login flow which I used in my UI. but only for CLI, right? And by the way, the application access CLI flow is a new that we're going to be taking a look at is a new feature in 6.1 release, which we just put out just a few days ago, I think on Friday or Monday. Yeah, we're going to have like another webinar sometime next month, I think, to go into more detail about the features that were released as a part of 6.1. And I believe Anadelia will put a link to that webinar in the Slack channel if you're interested in checking it out. But otherwise, let's keep looking at this app access CLI flow, right? So now as I'm logged into my cluster here, I can use, so again, for folks who are familiar with Teleport or not familiar, there's tsh-ls command that gives you all the servers that are currently registered in the cluster, right? And by the same analogy, there is a new command that's called tsh-appls that shows you all the applications that are connected to the cluster. And here you can see, I see the same two, which I originally saw in my control panel, right? Just because my permissions only allow me to see these two. And now let's say I wanted to make a request to one of these applications, right? So let's take this dumper app again as an example. So in response, I would expect it to return me like a headers. And so in order to call the applications API, the first step I need to do is to retrieve like a client certificate, right? Like I mentioned in the beginning, Teleport uses client certs for authentication with everything, and web apps are not an exception. So if I execute this tsh app login command, what it'll do is it will retrieve credentials for these particular applications, as in credentials specifically meaning X509 short-lived cert for this app, and gives me an example curl command that I can use to, with proper paths to all the secrets filled in and the application public URL filled in. So I can just copy and paste it, which in this case, it's a very simple app. It replies to any request. So I don't even need to modify this command, just can call it like this, right? So this way, basically, I used curl to call this app's API, and as expected, in response, it just gave me all the same headers which we saw before in the when we went through the UI access flow, right? So now let's just, for the sake of a demo, try to log into a different application. So this Wi-Fi router thing that I have, and you can be logged into multiple apps at the same time, right? Like we're seeing here. So I can also use very similar kind of flow to call my router's API if I want to. So I think it's API v1 status path to do something a little bit and spit me out the status of my Wi-Fi router. Hopefully it's working. So now let's say I also want to make a request to my Grafana instance, right? And again, similar to our UI example, I don't see it right now just because my user doesn't have permissions. So I actually need to go through the same request approval workflow as I did before to gain like additional access. And to do that, I can execute this tsh login request roles app command, right? Which, again, similar to user interface, it puts in a additional role request for myself, which I'm again going to go ahead and approve for myself now using the CLI flow. So now that I've assumed an additional role, you can see my status now changed to include this app role and execute tsh appls. As expected, I can now see all the other apps that are actually connected to my cluster and can interact with them as well. And let's just go ahead and log into this Grafana application here and just try to call its API, just again for the sake of the demo. So if I do it this way, right? So I know the Grafana has this API users endpoint, which requires like a privileged user. And obviously, if you remember when we're talking about how Grafana is configured, it uses JWT authentication. So in my case, it authenticates me automatically as this Roman T user, which is just a regular standard user, which currently doesn't have permissions to call this user's API, which is why I got this permission denied there. But what I could do is just authenticate as a user, which in my case is just default installation. So I didn't change a password, admin password or anything, test installation. So, but if I provide like a basic auth header to curl, you can see that it actually now lets me through. So that is just to demonstrate that all the headers are kind of getting passed through application access, so you can supply authentication info and so on and so forth when calling applications APIs. All right, once we're done here, let me go ahead and log out of everything. So the TSH app logout command clears all the credentials that we retrieved, right? Which is because we're using short-lived mutual TLS, short-lived client certificates, those credentials would have expired on their own in a few hours at all, but it's always a good practice to kind of explicitly remove all secrets when you no longer need them. And let me log out of my teleport cluster as well. All right, so this concludes our demo. Hope it was informative and useful. And let's get back to our presentation to wrap up. If I find my browser. All right. So before we wrap up here, I just wanted to mention that web applications, which were our main topic for today, is a part of a larger teleport access plane, which also can provide access to servers, Kubernetes clusters, and databases such as Postgres, MySQL, and soon MongoDB, with the same features as RBAC, auditing, session recording, access workflows, and so on and so forth. So if you're interested in any of these other types of access as well, feel free to check it out. Now for the next steps, you just can take a look at our application access documentation, right? And our getting started guide, which is really quick. So it's literally get you started in 10 minutes. And everything we've talked about today is open source. So you can go ahead and download the open source edition of Teleport right after this call if you're interested, and start playing with it and try out all the things that we've seen today during the demo. So go ahead and start exploring. Thank you everyone for attention. And now I believe we have some time left for Q&A.
Excellent. Thank you for a great presentation, Roman. It looks like we don't have any questions at the moment, but if people want to reach out to you after this presentation, what is the best way to get in touch with you?
Yeah, so I think a good way would be to, first of all, join our community Slack, which is, I believe, just go teleport.slack.com, right? If you have a link handy, and Adelia might be helpful to put it in chat. And we have the GitHub discussions as well, right? So we're using GitHub discussions to facilitate discussions with the open source community. So if you're running into any issues, have any questions for us, feel free to use either community Slack or GitHub discussions, and we'll be happy to chat to you.
Perfect. Thank you. Thank you, Roman, for a great presentation. This recording will be sent out to everyone who has joined today. So you should expect to see that later today in your inbox.